Okay, one of the ways that we can describe function is like a function behaves like a machine. Okay, so when you have a function fx, we have a input, or we call it x. After going through a function, we get an output, we call it y. Yeah, x is your object, y is your image. But what if I connect this machine fx to another machine, let's say gx? Okay, so the output from the first machine fx is y, is now inserted into as an input for the function gx. Now this gx will now give us another output, and yeah, we can call it whatever lah. We call it z if you like. So now we have two connected machine. Okay, now the function that happens first is f, the function that happens later is g. Notation wise, we write the one that happens first on the right hand side, follow the one on the left hand side. Okay, so example, I'll give you a very simple example. Let's say you have a function fx equals to x plus 2 and gx equals to 3x. So this function, or this machine if you like, its job is to first plus with 2 and then times with 3. So if let's say fx happens first, we write gf. Okay, let's say I'm going to put something inside. What do I put? I put 1 inside. Okay, so if I put 1 inside fx, the calculation works like this. We put 1 inside here, we go in, substitute 1 inside x here. So 1 plus 2 is 3, so you get g3. And what is g3? G3 means you put 3 inside your x here, so it's 3 times 3, answer is 9. Okay, now on the other hand, if I give you fg1, it means different thing. fg1 means we start by putting 1 inside your gx here, so it's keep copying your f. This is 3 times 1, which is f3. Now I put the 3 inside your x here, you get 3 plus 2, you get 5. Notice the difference. One is putting, the first one is substituting 1 inside f. Whatever you get, we put inside g. The second one is you substitute 1 inside g. The output, if you like, you put inside f. Okay. By the way, fgx or gfx is not the same as multiplication. It's not multiplication, right? Understand that, right? And gfx and fgx may not be the same. I've proven to you here, they may not be the same value in the end. Okay, so let's go straight to one example. Example number 15. So in this example, we want to find hg4. hg4 means we substitute 4 inside g. Look at your g. Your g is 5 minus x. In this case, 5 minus 4. So 5 minus 4 is 1. Once you get 1, you substitute inside h is 1 over 3. 3 times 1 is 1. U minus 4. Answer is also 3 minus 4 is negative 1. 1 over negative 1, still negative 1. Okay. The next one, I'm going to put h inside 2 inside h. When I put 2 inside h, is going to look like this: 2 over 3 times 2 minus 4. Okay, 3 times 2 is 6. 6 minus 4 is still 2. 2 over 2 is 1. Whatever you get, we put inside g, so it's going to be 5 minus 1. Answer is 4. Okay, not difficult, right? Subtest 15. So fg negative 2 means I'm going to put negative 2 inside g. So I put 2 times negative 2 plus 1. This is negative 3 plus 1, which negative 4 plus 1, which is negative 3. Yeah? So whatever I get, I'm going to put inside f. So it looks something like this: 3 times negative 3 minus 7, which is minus 6, minus 9 minus 7, which is minus 16. Okay? On the other hand, if you have gf5, we have to put 5 inside f. Now look at what you have for f. F is what? 3 times 5 minus 7. Yeah? Fx is 3x minus 7. If I put 5 here, I must put 5 here, remember? So this is 15 minus 7, which is 8. G8 means I've substituted 8 inside here. So it's 2 times 8 plus 1. 16 plus 1, 17. Example 16. So here we have GHX. Now we have to give your answer in terms of x, okay? We don't substitute exact value. So what is GHX? GHX means I put HX inside GX, okay? I need to think this way, okay? Maybe I just write this first. My HX is x squared minus 2x plus 5. Now I need to think this way. GX is given as 4x plus 3. If I put 1 here, and you put 1 here. Okay, I need to draw a little bit bigger, it's too small. Okay. If I put bracket here, I must put 4 bracket plus 3. What if I put a boy here? I will have to put a boy here. What if I put the, what do you like? X squared. Yeah, this will be x squared. So whatever I sub inside the bracket, I must sub inside over here accordingly, right? So, but in this case, what are we substituting inside? We are substituting x squared minus 2x plus 5. So on this side, I also have to put x squared minus 2x plus 5. So let us put this bracket and the 4 in front and plus 3. So it's x squared minus 2x plus 5. So when I multiply inside, you get 4x squared minus 8x plus 23. Okay. Now on the other hand, for B, you're finding HGX, meaning we put GX inside HX. My GX is 4x plus 3. Now think this way. HX is x squared minus 2x plus 5. So if I put 4x plus 3, I should put 4x plus 3 here and a 4x plus 3 here. You have to substitute twice, right? Because you have double x here. So just copy this down. 4x plus 3 squared minus 2, 4x plus 3 plus 5. So when you expand, you should get this, right? Let us simplify further. 24 minus 8, 16. 9 minus 6 is 3. 3 plus 5 is 8. Yeah, that's my answer. Okay, self-test 16. So here, you're given function f and g. You're supposed to find gfx. Now, what is gfx? Gfx means we put fx inside gx. My fx is 3x plus 2. I sub inside g. Now, again, I need to think this way. G bracket is 5 minus 4 bracket. Okay, what do I put inside the bracket? 3x plus 2. If I put 3x plus 2 here, I should put 3x plus 2 here. So what I need to do is to sub in a 5 minus 4, 3x plus 2. So next, we expand minus 12x minus 8. So when you expand, this is what you'll be getting, right? 5 minus 3, 5 minus 8 is negative 3. Okay, the second one, what is this? FGX. FGX means we put GX inside FX. Okay, my FX is 3 bracket plus 2. Okay, can I write one more time? FX is 3 bracket plus 2. If I have 5 minus 4x, what do I sub in here? 5 minus 4x. So this is 5 minus 4x. So when you expand, this is 15 minus 12x plus 2, 17 minus 12x. Okay. Okay, self-test 17. So here you're finding expression for gfx. Now, what is gfx? Gfx means we put fx inside gx. Okay, my fx is x minus 1 squared. Okay, so remember gx is x plus 4. If I put x minus 1 squared here, I must put x minus 1 squared, but I don't write extra bracket, so I just leave it like this. Okay, so this is x minus 1 squared. You don't put another bracket, just write in this form. So I can actually expand and simplify this. This will be x minus 1. Sorry, I expand the bracket. This is in the form a plus b squared. Sorry about this. So, and I hope, guys, I know some of you are still very new to this. So this is from 2 maths, a squared plus 2ab plus b squared. Yeah, I know some people say, oh Terry, my teacher in school say should do like that. Yeah, I call this the dinosaur age technology. It's so outdated. Yeah, this is too slow, very slow. Cannot do this, right? So learn how to expand directly, quickly using this method, x squared. Okay, look at this is 2ab, right? So 2 times -1 minus 2 times x is minus 2x. And the last term is b squared, which is -1 squared. You get 1. So when you put it together, this is my answer, right? Now, next part, find the value of x for which g f x is now gx squared. Another thing, before I do this, understand that gx is x plus 4. So when I put x square, I also put x square here. Yeah, you don't want to take the gx and square. It's not the same. Gx square is not the same as gx bracket square. Not true. Okay? You only square the x, not the whole function. So moving on. You already know your g of x, which is x squared minus 2x plus 5. You know your gx squared, which means we square only the x, yeah, like I said earlier, x squared plus 4. Here we can cancel x squared and x squared. Left it minus 2x. 5 I throw over, I get -1. 4 minus 5 is -1. X is just half. Okay, I say this again, the x squared and x squared, you just cancel them. Yeah. Okay, you bring over to one side, you just eliminate each other. Okay. Self-test 17. So your final expression for hgx. Now hgx means we put gx inside hx. So I'm going to write, change the color. Okay, hgx means I put gx inside hx. Now again, hx is 5x plus 3. If I put 2x minus 1 here, I have to substitute 2x minus 1 here. So it looks like this, 2x minus 1 plus 3. So when you expand, you should get 10x minus 2. Now, also we want to find the value of x, given that hgx is now half of gx. hgx is 10x minus 2. My gx is 2x minus 1. So when I times over, I get 20x minus 4. This is 2x minus 1. Transfer over, I get 18x. Bring over, I get 3. 3 divided by 18. 1 over 6. More question involving a composite function. So here, you're given fx, okay? And your fx is now 3x plus 2. So we want to put -2 inside. Okay, so this is 3 -2 plus 2, which is -6 plus 2, -4. Now the next part is find the value of k such that g f -2 is now 13. Okay, what is f -2? F -2 means you put -4. -4, right? This is -4, right? You sub inside. The result is 13. Okay, now look at this. Your gx is kx minus 7. G -4 is k -4 minus 7. The result is 13. So if I transfer over, minus 4k is now 20. K is now -5. Moving on to self-test 18. So here we are finding the value of m given that GH3 equals to 6. Okay, it's a little bit different from the question, my question just now, because my example is more guided. This is not. So because you need to figure out what is H3 first. But maybe I keep a G here. I just want to highlight to you, this is H3. We want to do H3 first. And H3 simply means putting 3 inside your H here. So it's 5 minus 3. What is 5 minus 3? 2, G2. G2 is 6. So now I substitute 2 inside here and here. So it's m over 2 plus 1 is 6. M is now 18. Example 19. So here we are finding expression of B in terms of A. So number 1, you can see that NM, Nigeria, Malaysia, is 4 over x plus 6. Okay, so we want to combine these two as well. NMX means we put Malaysia inside Nigeria. Okay, NX is half x plus b. If I put 8 over x minus a, I must put 8 over x minus a inside here, so it looks something like this. Now, what can I do with the half? I times in, half and 8 can cancel, 4 over x minus half a plus b, and NMX is also given here, which is 4 over x plus 6. So what we can do is we can compare. Now, no point comparing these two. You can see these two are actually the same now. Okay, so what we want to compare is the one without any x. We call this a constant, and this constant, right? So if you want to compare the constant, yeah, we can write, okay, comparing constant, 6 is now negative half a plus b. Since I'm finding b in terms of a, I'm going to bring this over. B is half a plus 6. Okay. Okay, self-test 19. So here you're given fhx is equals to 5bx plus q. Your hx is 5x minus 2. Okay, maybe I write fhx here first. So remember, fx is bx plus 3. So whatever I put in here, I must put the same things here. So this b of 5x minus 2 plus 3. If you sub inside 5bx minus 2b plus 3, and this fhx is this 5bx plus q. Now notice the bx are the same now. These two are the same now, so no point comparing this. We just have to compare the one involving constant. See, same thing here. So we compare your constant. That means q is minus 2p plus 3. 2p is 3 minus q. p is 3 minus q over 2. Okay? Okay, example 20, you're given gfx. So I think we start by putting fx inside gx, because you already have this gfx here, right? So you want to put this fx over here into your gx. So gx is given as kx squared plus n. So whatever I put inside here, I must put the same thing. And in this case, if I put 3 minus x, I must put 3 minus x over here. So let's write k 3 minus x squared plus n. Okay, next we're going to expand this. 9 minus 6x plus x squared. This is n. Multiply inside 9k minus 6kx plus x squared plus n. Let us just rearrange it. Maybe I follow the sequence here. I have a k here. Sorry, I missed out a k here. So this is k x squared minus 6kx plus 9k plus n. And copy the given gfx on the left. Okay, by comparing. Now which one can I compare? We can compare x squared. The number in front of x squared here is k. This is also k. So my k is what? My k is 2. Now no point comparing the second one, because if you compare the second one, what will you get? I will get k equals 2 again. Alright, because I already have k. So what you want to do is you want to compare the constant. The constant is here and here. Can you see? You want to compare the one without x, we call it constant. So 9k plus n is now your constant 5. Since k is 2, I bring over 5 minus 18 is negative 13. Okay, self-test 20. So here we are given fx, gx, and gfx. Gfx means we put fx inside gx, okay? Now, your gx is 2x plus 16. If I put ax plus b here, I must substitute ax plus b here. So write this as 2 bracket plus 16 ax plus b. Your gfx is already given here, which is 6x plus 18. So just expand 2ax plus 2b plus 16. When you compare, please compare, say, coefficient x with coefficient x, and compare, say, constant with constant. So maybe I start off with comparing x. The number in front of x is 2a here. I equate it with 6. A is 3. I compare my constant. 2b plus 16 is 18. 2b is 2. B is 1. Okay, let's move on to repeated function, or we call this iterative function. So iterative function simply means a function that repeats itself. So for example, if I give you f2x, we write this as fx. Now take note that f2x is not the same as fx squared. It's not a square, it's not a function that you square it. It's just putting a function fx inside function fx. Okay, let's go straight to one example. So in example 21, you're given gx equals to x squared plus 3. And I want to find g2 negative 1. g2 negative 1 simply means gg negative 1. So we put negative 1 inside g first. So in this case, you get negative 1 squared plus 3. Okay, negative 1 squared is 1. 1 plus 3 is 4. So this is g4. Now, g4 means we put 4 inside g again. So 4 squared is 16. 16 plus 3, 19. Okay, not that difficult, right? Now, the next thing is, what if I want just in terms of x, like g to x? G to x means ggx, okay? So I'm going to put gx, which is x squared plus 3, inside gx again. Now, I need to think this way. Now, when we say gx equals to x squared plus 3, I can put x here and this will be x. I mean, I can put x here, this will be x. Am I right? But now we don't want to put x inside. What we want to put is this bracket, x squared plus 3, x squared plus 3. So we write this as x squared plus 3 squared plus 3. As I expand, remember the expansion of a plus b squared? Yeah, a plus b squared will be what? A squared plus 2ab plus b squared. But instead of a normal linear term, this is x squared. So x squared, when you square it, you get x power 4. Then you take 2 times 3, which is 6. 6 times x squared, 6x squared. And 3, if you square, you get 9 plus 3. Answer is x power 4 plus 6x squared plus 12. Okay. Okay, moving on to self-test 21. So here you have function fx equals to 2x minus 7. And the first part you're finding f23. f23 means f3. So f3 means we substitute 3 inside your function fx. So I'm going to put 3 inside x. So this will be 2 times 3, 6. 6 minus 7, negative 1. So once again, whatever we get, we substitute inside. 2 times negative 1 minus 7, answer negative 9. Now, how about f2x? f2x means ffx. So we put 2x minus 7 inside. Again, remember, fx is 2x minus 7. If you have 2x minus here, 2x minus 7 here, you need to put the same thing here, 2x minus 7. So this is 2x minus 7, which gives us 4x minus 14 minus 7, 4x minus 21. Okay, the next part, example 22. This is something new in your new syllabus. They started to new KSSM syllabus. They have questions something like this. Okay, so we start off with finding f2x. Okay, now your function now looks a little bit more complicated because of the fraction. So I'm going to put fx 1 minus x over 1 plus x inside my fx. Now please take note, fx is 1 minus x. So you got a thin bracket, 1 minus bracket, 1 plus bracket. Okay, what do you put inside the bracket? Normally we put x. Yeah, if you look at this, this is x. But now we're not putting x, we're putting 1 minus x over 1 plus x, 1 minus x over 1 plus x, and 1 minus x here over 1 plus x. Okay, follow the same pattern. I'm going to sub in here. Okay, 1 plus 1 minus x, 1 plus x. Okay, now how would you simplify this? Now most people would just combine everything to a single fraction. You know, you multiply top and bottom of a 1 with 1 plus x and all that. I don't want to do that. I think it's a little bit slow. It's like if I give you 2 over 3 over 5 over 3. Okay, maybe not. Maybe I give you 1 plus, okay? Now what most people would do, they would say, oh, this one is 3 plus 2 over 3. This is 5 over 3. Then this is, okay, maybe I shouldn't use 1. 1 is too easy. Okay, I'll just use a 2 instead. So they'll say this is 6, okay? So this will get 8 over 3. When you divide 5 over 3 is times 3 over 5. Then you cancel, you get 8 over 5. So this is what most people would do, right? But I would say if you get 2 plus 2 over 3, 5 over 3, why don't you just times top and bottom with 3? So you get 6 plus 2 over 5, 8 over 3. 8 over 5. So wouldn't that be faster? Yeah, just multiply top and bottom with 3 just to get your fraction. Yeah, so you don't have to deal with big fraction. So now coming back to this question, instead of using number, we have algebraic expression. So I would just multiply the top with 1 plus x, denominator 1 plus x. So this is 1 plus x. At the same time, this negative, I'm going to multiply inside. So it's minus 1 plus x. Denominator is 1 plus x plus 1 minus x. Now remember, as you multiply with 1, what do you call that? 1 plus x, these two cancel. Yeah, okay, it's a bit mild, cannot see. Okay, these two cancel. You see? Yeah, but of course, this 1 plus x must multiply with the 1 as well. That's why, yeah, you have the 1 plus x over here and 1 plus x over here. Alright, okay, I'm simplifying this further. This will be 2x because 1 minus 1 cancel out, left with 2x, right? Your denominator left with 2, answer is x. Now, when you get f(x) equals x, what's the meaning of that? Remember, when we say f(x) equals to x, we say that the function is mapped onto itself, right? That means when you start off with x, you get over to here, your f(x) still gives us the same thing, right? So if I have f(2x) on the other hand, yeah, it looks something like this. Maybe your first function, okay, I'm going to click this one. I just want to draw nicely over here, okay. Okay, let me talk about the concept again, one more time. So you want to find f21x, but before we understand f21x, let's handle this first. When I say fx, right, my fx is 1 minus x, 1 plus x. So the result is 1 minus x, 1 plus x here. Yeah? But the moment you do f2x, you will get back x here. Can you see? So that means if I do this function one more time, go through the function one more time, you will return to, this is how we write 1 minus x, 1 plus x, because this is now your object, this is now your image. So you get back to the same position where you started. Alright, so because of that, I can give you f3x. And you look at how it moves. So let's say f3x means it goes like this. 1 is fx, f2 is over here because you do one more round, f3 will go back to 1 minus x, 1 plus x. So f3x will give us 1 minus x, 1 plus x. How about f4x? f4x will be going this direction. See, 1 to the right, 2 to the left, f2, f3 go back to the right one more time, f4 return to x. So it's like a ding dong thing. You know, when you go odd number, you end up at fx. When you get even number, you go back to x. You can go round and round 20 times, 40 times, the result's the same thing. Okay, so the way you write your answer, you can write in, you know, this way, f21x, right? Okay, although it's a big number, but we know this is an odd number, and we know every time you get to f2x, you get the x, right? So if I give you f2, let's say f3x, you need to think f2 fx. Remember, f2x get us back to x. If I put the fx here, I'll end up getting fx again. So you can say this is f2, f2, how many f2? 4. This is 4, 5, 6, 7, 8, 9, 10. Right? 10 f2 will give us 20 and the single fx. Right? Now, the rest of this, when you go through the function, it will cancel each other out. f2x is, remember, f2x is the same as x. So all this will just, okay, I need to use a different color. All this will just cancel each other out, and you end up getting fx, which is 1 minus x, 1 plus x. Now, if you don't write this, there's another way. You can just write the other direction. Let's say, what do you write? F first, then followed by f2, f2, 3, 4, 5, 6, 7, 8, 9, 10, and all these fx, f2x will give us x. So you're left with just a single fx, which is 1 minus x, 1 plus x. Right? Okay. You get the point, huh? So up to you whether you want to write the first or the second. I think I'll just keep both of them here. Yeah, up to you. Okay. So, and always remember, right, x cannot be -1 here, x cannot be -1 here. Right? Okay, moving on to self-test 22. Okay, this one is a easier version, because the function is a lot easier. Yeah, 3 over x. So let's start off by writing gx. Okay, what is gx? Gx is 3 over x. So when you put gx, g bracket, 3 over bracket, so if I put 3 over x here, I need to sub 3 over x here. So I'm going to write 3 over 3 over x. When I flip this upside down, the result is just x. Okay? Now, the next thing is, what is g15x? Well, g15 simply means we do 15 times, but I'm not going to do right like this because this is g2. Remember, let me clarify this. Gx is here. I go through this function, I get 3 over x. I do one more time, I'll get back the same thing as x. So this will be g, can I write g2? How many times? I want 15, so 15 should be 7 times 2, 14, so I need 7 of this and a single gx. Yeah, okay, I need one more. This is 7, okay, 7 g2, a single gx. So this, all this will cancel each other off. You get gx, which is the same as 3 over x, where x cannot be 0. Okay, let's continue example 23. Now, here we are given hx equals to 2x plus 1. And the first part, we are finding h2x. h2x, remember, is hx. So I'm going to put hx inside hx. In this case, is 2x plus 1. And always remember, hx is 2x plus 1. If I put a bracket here, I need to put 2x plus 1 inside and 2x plus 1 inside here. So this is 2 bracket 2x plus 1 plus 1. So the result is 4x plus 2 plus 1, which is 4x plus 3. Okay. Now, how about h3x? Okay. h3 simply means we do h2 followed by hx, or we do hx followed by h2, up to you. So maybe I just write h2x. Okay. I really know my h2x. It is 4x plus 3. And remember, my hx is 2 bracket plus 1. Just keep thinking this way. If I put 4x plus 3 here, I must put 4x plus 3 here. So this is 4x plus 3. As I expand, I get 8x plus 6 plus 1, which is 8x plus 7. Okay, now how do you go from h3 to h4? Okay, now you can choose to do h3 and hx, or h and h3, or you can just use H2, up to you. What do you think? I think I'll just use H and H3. Now, since I know H3 is 8x plus 7. My hx is still 2 bracket plus 1. So I put 8x plus 7, 16x plus 14 plus 1, 16x plus 15. So I've got H1, H2, H3, H4. Okay, now part D, you need to analyze and see a pattern here. Now, maybe I list down for you. Okay, so it's in order for you to see or understand this better, I'm going to list down. This is 2x plus 1. H2 is 4x plus 3. H3 is 8x plus 7. H4, 16x plus 15. So what do you see? Now, number one, you can see that the coefficient of x, there's a pattern here. This is 2, this is 4, this is 8, this is 16. So what we can conclude is that the coefficient of x is actually in the form of 2 power n. So this is hn, right? For example, if this is h1, this is 2 power 1, right? And the second one, 4 is 2 power 4 here is 2 power 2. 8 here is 2 power 3. 16 here is 2 power 4. So this will be 2 power n, right? Then you look at the second number. Okay, now the next term is your constant. Can you see what's the relationship? Now it's harder to think 1 to 3, 3 to 7, 7 to 15. It's harder to think this way, but I want you to look at the number, the relationship between this number and the term before. Can you see now? What's the relationship? Is 1 less than the coefficient of x. So if your coefficient of x is, for example, if your coefficient of x is 2, this is 1, 4, this is 3, 8, 7, 16, 15. And if this is 2 power n, you need to think 2 power n minus 1. Okay? 2 power n minus 1. So I've got this general formula for part D. And with that general formula, we can find part E here, H9. So H9x is 2 power 9x plus 2 power 9 minus 1. Okay, what is 2 power 9? We can count. Use a calculator if you can't do it mentally. 512. And if this is 512, the next term should be 1 less, 511. Okay, so what we are doing is we are using an inductive method, we call it, to come up with the general formula so that we can find a bigger value like H3, H10, H20, or H100 if you will, right? So, you okay with this? Okay, for your self-test 23, a function f is defined by this, fx equals x over 1 minus x. So you're finding an expression of f2x. So f2x means f(x), okay? So we are putting fx inside fx, x over 1 minus x, okay? Now the next thing is, remember, fx is x over 1 minus x. So whatever we put inside here, you must substitute accordingly. So this will be x over 1 minus x divided by 1 minus x over 1 minus x. Okay, now to simplify this further, we should multiply top and bottom with 1 minus x. By doing so, I can cancel out this denominator, and this part will be 1 minus x, right? Just show you here, you can cross out. Hope it's clear enough. But remember to multiply the 1 minus x with 1. So this will give us x over 1 minus 2x. Yeah? Right, x not equals to half. Now, how about part B? This is part A, f2. If I want to find f3, so again, you got to repeat the process. Now, it's up to you which one you want to use. You want to use the f2 or f2f? Also can. So I think I'll just use f2. Why? Because I really know I just keep using this fx thing, and the fx again is bracket 1 minus bracket So what do you put inside the bracket here? X over 1 minus 2x. So is x 1 minus 2x divide 1 minus x 1 minus 2x. Again, you got to times top and bottom, but in this case you multiply top and bottom with 1 minus 2x. So this will give us x over 1 minus 2x minus x. You cancel out your denominator and we get x over 1 minus 3x. Okay, can you see a pattern already? This is much easier compared to the earlier one, right? Because if you do 2 times, you really see, you can see a pattern here, right? Okay, you still can't. Let me show you. Okay, let me write down. Fx is x 1 minus x. F2x is x 1 minus 2x. F3x is x 1 minus 3x. Can you see the number here? This one. This is 1. This will be 1. This is 2. This will be 2. This is 3. This is 3. Right? So I want to find a general formula for f and x. So we can write this as x over 1 minus nx. Right here, n cannot be, oops, n cannot be, x cannot be, why am I erasing the right thing? This one of n, sorry. Okay, so now with that, we can find f12x, okay, but the f12x. So it's going to be x over 1 minus 12x. X cannot be 1 over 12. Okay. Okay, let's move on to example 24. So here we have function fx equals to px plus q. F2x is 16x minus 15. Find the values of p and q. Okay, let's start. Now, f2x means fx. So I'm going to put fx inside, which is px plus q, right? Now, the thing is, your fx is px plus q. So if I put px plus q inside here, I need to sub px plus q inside here. So it looks like this, p of px plus q, which is p square x plus pq plus q. And your f2x is also 16x minus 15. Now we've done the comparison method in GFX, FGX, right? So this is the same thing. We are using comparison to find the values of unknown. So, but when you compare, which one should I compare? I should compare x with x, coefficient x with coefficient x. Some more. I should compare constant. Okay, this is too light. You can't see constant with constant. Yeah, constant is the one without any x. So, let's start by comparing coefficient of x. Okay, so p square is now 16. P is, by right we should put a plus minus, but always read and look at the question. The question here asking for positive value of p, so we ignore negative 4, just take positive 4. Now, as for your constant, when you compare your constant, the number in front of constant is, the constant actually is pq plus q. You equate it with 15, yeah, negative 15 on the left. So since p is 4, we can sub inside. Okay, so 5q is negative 15, q is negative 3. Okay. Okay, let's move on to self-test 24. So this question is rather, I feel it's too similar to example, but what to do is a similar past year question, 2007, and it's quite similar to 2001, the old one as well. Okay, now we want to start off by finding h2x, yeah, and h2x is basically hx. In this case is ax plus b, so we're going to put inside a of ax plus b. After some time doing this, I think I don't have to write this down for you, right? H bracket thing, yeah, you can just straight away write in this form. So this is ab plus b. My h2x is given as 25x plus 12, and again I need to compare. So when you compare coefficient x with coefficient x, maybe constant with constant, right? In this case, my coefficient x is a square, and a square is 25. Again, a is more than 0, So you take a equals to 5. Yeah, maybe I put a note here, more than 0. As for constant, you have a, b plus b, and it's now 12. My constant is 12. 5b plus b is 12. 6b is 12. B is 2. Okay, it's not difficult. Okay, now for composite function, normally if I give you, let's say, a function f followed by function g, and we can find this as g of x. If you're given fx and gx, to find g of x is not difficult. You put fx inside gx, then you calculate this. That's it. Okay, the thing that makes it difficult is this. If you're given g of x and you're given gx, can we find fx? Right? You have to work backwards. Okay, here already written down for you, but it's good for me to give you a pre-example before you do one of the example. The idea is, when you're given two functions like this, g fx, it's a bit hard to work on two functions. So what we want to do is we want to narrow down or reduce it to one function, and we can do that now. Don't worry, I'm just copying down the same thing as I explained. All right, you let the function inside becomes y. Now when I say function inside, means the function that happens first, the function on the right, in this case your fx. So we let your fx becomes y, so you get gy equals 6x plus 5. Okay, by doing that, I'll narrow down from two functions g of x to only one function gx, and we are given gx as well, right? You see, gx is 2x plus 1, therefore gy will be 2y plus 1. So what I want to do is I want to find y. So when I bring this over, I get 6x plus 4. My y is 3x plus 2. And what is your y? Your y is your fx. So fx is 3x plus 2. Okay, now we're going to do one example. Okay, this is similar. Yeah, the idea is the same thing. So always remember to start by letting the function inside. In this case, for my example 25, my fx equals to y. Okay, by letting fx equals to y, now I'm not going to write g fx, I'm going to write gy. Yeah, I would effectively reduce it from multifunction gfx to a single function gx. Gy, sorry. Now the gx we already know is 1 minus 3x, so gy will be 1 minus 3y. Okay, so what I want to do is I want to make y as a subject. Bring over 10 minus 1, I get 9. Here when I divide by negative 3, 9 is negative 3. Negative 12 divided by negative 3, this is 4x now. And what is your y? Your y is your fx, and your fx is 4x minus 3. Okay, now moving on to part B. So here you're given hx equals to 4 over x, and hfx is 12 over 1 minus x. So what we do is we let the function inside becomes y. So by doing so, your hy, your fx now y, is now 2 over 1 minus x. Okay, we have effectively reduced it from two functions to a single function. And then we have hx. Hx is 4 over x. Hy will be 4 over y. So this is 2 over 1 minus x. Now remember what are we finding? We're finding for y. Okay, y, which is hx. So I can cancel this out. Yeah, I hope you know how to cancel this directly. Yeah, 4 and 2. Sorry, a bit ugly. So this is 2 here. A bit mild, I cannot see. Right? Yeah. So then I cross multiply. Yeah, when I cross multiply, you get 2 minus 2x equals to y, right? Then your y is your fx, your fx is 2 minus 2x. Okay, that's your answer. Okay, self-test 25. So here we have hx, hgx. Okay, so we let gx, which is the function inside, equals to y. So you don't want to write gx, you want to write y, so that we can narrow down or reduce it to a single function hy. Now we know hx is 12 over x, hy will be 12 over y. The result is 4x. Now I want to find y, so I bring the y up, I bring the 4x down. I wonder whether you can do this in one step, guys. I would hope that you can just bring this up, bring this down, one step. Yeah, So this will be 12 over 4x equals to y, and your y is 3 over x. Okay, now your y will be your gx, and your gx equals 3 over x, where x cannot be 0. Okay, let's look at your part B. Your fx is given, fgx is given, so we let the function inside gx becomes y. I don't want to write gx, I'm going to write y here. The result is 5 minus 2x squared. Now remember, your fx is 9 minus 2x, your fy will be 9 minus 2y. Okay, so by rearranging this, 2y is now, okay, I do a little bit slow. I bring the 9 over first. So I get negative 2x squared, negative 4. 5 minus 9 is negative 4. Then I divide by negative 2. So this is positive. This is also positive. Negative 4 divided negative 2 is positive 2. Okay, with that, I got my y ready. My y is my gx. My gx is x squared plus 2. Okay. Okay, the next part we are working backwards, because previously you're given the function outside, yeah, and gfx, and you're finding function inside fx. So this is the other way around. So let me show you this one. We can use this is your fx, this is your gx, this whole thing is your gfx. Yeah, now I'm given fx, I'm given gfx, and I'm finding gx. Okay, the starting point is the same. The starting point is the same. We always let the function inside becomes y. Reason being, again, I want to reduce from 2 function to 1. But in this case, a little bit complicated, because we are now finding g. We are not finding f. We are given f. So to find g, to find gx, I must first find gy. Now, you cannot have gy in terms of, you can write gy in terms of x. They're different, right? So you want to write gy in terms of y. For example, I like to give this fruit equation. Okay, so like if I say f apple is 2 apple plus 5, then I can conclude fx is 2x plus 5. But if I have f apple equals to 2 oranges plus 5, then they are not the same fruit. So, but if I know 1 orange is equivalent to 3 apples, and let's say minus 1, then I can replace the orange with 3 apple minus 1 plus 5. And if I can write this minus 2 plus 5, this is plus 3. If I can express apple with apple, then we can say fx equals to 6x plus 3. Yeah, we must compare the same fruit, right? Okay, sounds like a fruit equation. So, but anyhow, you get the idea. So we need to basically change this x into y. So the question is, what's the relationship between x and y? Now we go back to the function fx. Yeah, we already know fx is y. So fx is 3x plus 2, and 3x plus 2 is y. So by making x as a subject, y minus 2 over 3, I can substitute this x into here. Can you see? And gy is therefore 6 of y minus 2 over 3 plus 5. As I cancel them, you get 2y minus 4 plus 5. So your gy is 2y plus 1. Okay, if I can write gy equals to 2y plus 1, then gx will be 2x plus 1. Okay, this method, substitution method. Later on, I'll show you the inverse method. After we finish after we finish this, we'll do inverse function. I'll teach you guys the inverse method to find this. Okay, moving on to example 26. And now that I've given you a pre-example, you get a rough idea. Let's just move on and do one question. So your gx is given, your fgx is given. We start by letting the function inside becomes y. So your gx is now y, so I write y inside here. Now I know I'm looking for fx. Before I find fx, I must find fy. The question is, what's the relationship between x and y? I know gx is 3x minus 2. Okay, from here. So I make x as a subject. Okay, x is now y plus 2 over 3. And I will take this and substitute inside here. Okay, the moment you substitute, you can cancel 3 and 3. You get 11, the negative times inside, minus y minus 2. My fy is now 9 minus y. If fy is 9 minus y, fx is 9 minus x. Okay, not difficult, right? Okay, but in a way, some people may say you got to remember the step involved to a certain degree. If you understand the concept, I think it's not that hard, right? So the second one, you have gx here. So we let the function gx becomes y. This is fy, and the result is x squared plus 8x plus 5. Now you go back to the function gx. Gx is x plus 4. So x plus 4 is y. X is now y minus 4. Take this x and replace it in here. Okay, as you expand, this will be y squared minus 8y plus 16, 8y minus 32 plus 5. I hope you can expand this rather quickly by now. So minus 8 and plus 8 cancel, left with 16 minus 32, negative 16, negative 16 plus 5, negative 11. Okay, so if I got fy equals y squared minus 11, therefore fx will be x squared minus 11. Okay, moving on to self-test 26. So here we let the function inside fx equals y. So hy is now 5x minus 9. Okay, remember we are finding for hx. To find hx, I must change all the x into I must first find hy. I must change all the x into y. So go back to your function here. Fx is x minus 6, and x minus 6 is now y. X is now y plus 6. By replacing your x with y plus 6, we can expand and simplify this. Your hy is 5y plus 21. Therefore, hx is 5x plus 21. Okay, not difficult, right? So, moving on. Your part B here, we let gx becomes y. So this is hy, and hy is 4x plus 7. Remember, gx is x over 2 minus 1 from here. I need to make x as a subject, so I plus over and times 2. So this is 2y plus 2. So if x is 2y plus 2, we can sub inside here and we expand the bracket. Therefore, hy is 8y plus 15. And we are finding hx. So if hy is 8y plus 15, hx is 8x plus 15. Okay.